For more than a century, humanity has been speaking into the cosmos, though not with the careful clarity of a diplomat, but with the careless chatter of a species that had only just discovered its own voice. Every baseball game carried over AM radio, every soap opera bouncing from rooftop antennas, every radar ping aimed at Venus, all of it has leaked outward, an unintentional confession that we are here. That confession races into the void at the speed of light, forming what astronomers call the radio bubble, now more than 130 light-years across. To anyone listening, our world is a small blue dot wrapped in a haze of electromagnetic noise, growing larger each day. But there are two types of voices in this bubble. The first are accidents, radio leakage, the spillage of a civilization that mastered the spectrum before it understood discretion. The second are our deliberate calls, messages carefully crafted, hurled into an ocean of darkness, and destined, perhaps, never to be heard. In the 1,970 seconds, we attempted something bold. Pioneer 10 and 11 were launched with plaques of polished gold, engraved with the figures of a man and woman, symbols of hydrogen, and a crude star map pointing to our Sunday. The logic was clear. Mathematics, physics, and the human form offered a universal introduction. It was also audacious, even naive. The plaques showed us naked, vulnerable, unarmored, holding out our hands in a gesture we hoped would be seen as greeting rather than surrender. A few years later, Voyager 1 and 2 carried the golden records, phonograph albums sealed in copper, designed to last 1 billion years. They contained 116 images of Earth's life and culture, the double helix of DNA, a mother and child, elephants marching across the savannah. They carried greetings in 55 languages, whale songs, and Chuck Berry's Johnny B. Good. The discs were more than music. They were an anthology of what it meant to be human. Astronomer Carl Sagan called it a bottle cast into the cosmic ocean. Critics called it graffiti on the stars. Yet the act of sending mattered. It was our way of saying, we exist, and we want to be known. But the loudest shout came in 1974, when Frank Drake and his team turned the 305-meter Arecibo radio telescope toward the globular cluster M13. For 3 minutes, the dish unleashed nearly 1 million watts of power, making Earth briefly the brightest radio source in the galactic neighborhood. The message was short, 1,679 bits, chosen because 1,679 is the product of two prime numbers, 23 and 73. To any mathematically literate intelligence, this was an invitation. Arrange the bits into a grid, and the picture emerges. A diagram of our solar system, a human figure, the double helix, and our number system. It was both crude and profound, a pixelated mural of our existence. Yet M13 is 25,000 light-years away. By the time the message arrives, human civilizations may have risen and collapsed 100 times. Still, we sent it, because sometimes the act of calling matters more than the certainty of reply. This impulse to call into the dark has deep roots. In the late 19th century, before radio was even practical, Nikola Tesla speculated that his wireless experiments might reach other planets. In 1899, he claimed to have detected unusual signals while experimenting with high-voltage coils in Colorado Springs. He thought they might be from Mars. Today, most dismiss it as interference, but Tesla's intuition was prophetic. The moment we gained the ability to speak beyond Earth, the question of who might be listening became inevitable. By the mid-20th century, scientists like Giuseppe Cocconi and Philip Morrison began framing that question with rigor. In 1959, they published a paper in Nature suggesting that radio waves, cheap, fast, and capable of spanning interstellar distances, were the logical medium for contact. They pointed to the water hole, the quiet region of the spectrum between the hydrogen line at 1,420 MHz and the hydroxyl line at 1,662 MHz. To them, it was the natural meeting place for civilizations. Hydrogen and hydroxyl, the ingredients of water, the universal solvent of life. Anyone who understood chemistry, they argued, would know to look there. That idea became the foundation of SETI, the search for extraterrestrial intelligence. Yet the paradox is this: our accidental transmissions, the noisy chorus of television towers and radio stations, fade quickly into the cosmic static. A signal powerful enough to cross interstellar distances requires staggering energy. Most of what we've leaked into space becomes indistinguishable from background noise within a few light years. Only our radar pings and intentional broadcasts shine brightly enough to be noticed far away. For all our talking, our voice is quieter than we imagine. And still, we keep calling, because silence feels more unbearable than the possibility of indifference. Each deliberate message is a gamble against cosmic loneliness. A plaque, a record, a 3-minute burst of radio. To us, they are fragile things. To anyone who might find them, they would be a revelation. The knowledge that across the abyss of space, something else dared to say, "We are here." In that sense, shouting into the dark is not just an act of science, it is an act of faith. Faith that somewhere, intelligence endures. Faith that the loneliness of our world is not permanent. And faith that if someone, somewhere, hears us, they will understand not only the content of our words, but the hope behind them. If the cosmos were a library, endlessly vast and filled with unread books, then scientists needed to know where to place the bookmark. Where, among infinite frequencies, would two civilizations choose to meet? In 1959, physicists Giuseppe Cocconi and Philip Morrison suggested a hauntingly simple answer. Writing in Nature, they pointed to the quietest part of the spectrum between 1,420 and 1,662 MHz. These frequencies, they argued, would be the natural place to listen. Why? Because they are defined not by culture, but by physics itself. At 1,420 MHz lies the hydrogen line, the frequency at which the electron in a hydrogen atom flips its spin relative to the proton's magnetic field. Hydrogen is the most abundant element in the universe, the raw material of stars. At 1,662 MHz is the hydroxyl radical. Put them together, hydrogen plus hydroxyl, and you get H2O, water, life's solvent. To Cocconi and Morrison, this waterhole of the spectrum was a kind of cosmic tavern, a universal meeting place. If aliens were listening, they would know to tune here. It was a profound idea. Communication need not be shouted into every corner of the electromagnetic sea. Instead, one could whisper in the hydrogen line, and the galaxy would know it was intentional. Whispering there is like leaving a note under a lamppost everyone recognizes. A code written not in English or Mandarin, but in the language of atoms. And so, SETI's great listening projects pointed their antennas toward this quiet corridor. The Allen Telescope Array in Northern California, 42 dishes working together. Breakthrough listened, scanning millions of stars for anomalies. Radio telescopes in Russia, China, Australia, all turning their ears toward the waterhole, straining for a pattern that does not belong. But what about us? What do we look like to anyone listening? To an alien astronomer, our planet already radiates like a peculiar beacon. Each TV station appears as a structured, narrow carrier frequency. Each FM broadcast adds to the noise. Planetary radars Arecibo's S-band, Goldstone's X-band sweep like lighthouses, broadcasting enormous energy with each rotation. Even if most of our signals fade into background static after a few light years, these radars cut through the silence, powerful enough to be seen across interstellar distances. And then there is the Deep Space Network. 3 vast antenna complexes, California's Mojave Desert, Madrid's plains, and the hills outside Canberra, Australia. Their 70-meter dishes maintain contact with Voyager, with Mars rovers, with probes on the far edge of the solar system. To an alien telescope, the pattern of our transmissions would be obvious. Bursts of power, precisely structured, repeating at regular intervals as Earth spins. A tiny, restless blue world wrapped in engineered pulses. If someone were watching carefully, they would already know we are different from the stars around us, different from the silent gas giants, the tumbling comets, the barren moons. We are noisy, and noise is rarely natural. Yet, curiously, our signals are fragile. The inverse square law is merciless. Double the distance, and a signal weakens to a quarter of its strength. Beyond a handful of light years, our sitcoms vanish into the hiss of cosmic microwave background. A civilization even a few dozen stars away would hear almost nothing, unless they, too, were listening in the hydrogen whisper, unless they, too, believed that the waterhole is where civilizations would meet. Aware of this fragility, we've tried to shield ourselves in pockets of silence. In West Virginia, The National Radio Quiet Zone covers 13,000 square miles, protecting the Green Bank Observatory from interference. Cell phones, Wi-Fi routers, even microwave ovens are restricted. The effect is uncanny, a valley where modern noise has been banished so that humans can listen for something beyond themselves. These radio quiet zones are like monasteries of science, where silence is cultivated in hopes of hearing a single voice from the stars. And there are rules too. The International Telecommunication Union sets aside specific frequencies to protect radio astronomy, a recognition, however bureaucratic, that if we fill every part of the spectrum with our own chatter, we will deafen ourselves to the universe. It is a rare example of global cooperation born of humility, a shared decision to leave at least a small slice of silence intact in case someone else is speaking. Yet no law, no treaty, no quiet zone can prevent the deeper tension that has always divided scientists. Should we only listen, or should we speak? Traditional SETI has been cautious, devoted to listening. Breakthrough Listen, Green Bank, Parkes, all of them combing petabytes of data for signals. The logic is simple. Listening carries no risk, but another camp argues the opposite. If everyone is listening, no one will ever be heard. They call it meti-messaging, extraterrestrial intelligence. They want to transmit powerful signals deliberately to announce ourselves with clarity. Their critics call it reckless. Who gave a handful of scientists the right to speak for Earth? What if the first reply is not a greeting, but a warning? The debate echoes something ancient. Thousands of years ago, tribes lit signal fires to announce themselves across valleys, not knowing whether the figures in the distance were friend or foe. Today, our fires burn at 1,420 megahertzes. The waterhole is our hilltop. Our fires are the whispers of hydrogen. But in whispers lies both intimacy and danger. To whisper is to reveal oneself, to invite another closer. To whisper is to hope that the silence will not answer with indifference. And so, the story of our first century of interstellar communication is not just about technology. It is about the psychology of solitude, about a species that fears being alone, yet also fears being known. We have spent decades straining to hear a hydrogen whisper in return, and what unsettles us most is not that the universe has been silent. It is the creeping suspicion that perhaps someone has already heard us. The search for voices among the stars has always carried a dangerous companion: the risk of mistaking echoes of nature for messages of intelligence. Our first brushes with contact were not conversations but misunderstandings, moments when the universe teased us with precision, only to reveal itself as something colder, stranger, and yet no less extraordinary. It began in 1967, when a young graduate student in Cambridge, Jocelyn Bell Burnell, noticed something odd in the miles of paper chart recordings spilling out of her radio telescope. Amid the noise, there was a pulse regular, unwavering, repeating every 1.337 seconds. It was as steady as a heartbeat, as precise as the ticking of an atomic clock. Bell and her colleagues nicknamed it, half-jokingly, LGM-1, Little Green Men 1. For a few weeks, the possibility of extraterrestrial intelligence lingered uncomfortably in the air. Could this be the beacon we had waited for? A signal meant for us? The truth was both more and less wondrous. It was not a message, but a neutron star, the collapsed corpse of a once mighty sun, spinning rapidly and beaming radio waves like a lighthouse. A pulsar. What Bell had discovered was not alien intelligence, but physics pushed to its limits. Matter compressed so tightly that a teaspoon weighed 1 billion tons, magnetic fields trillions of times stronger than Earth's. The discovery was revolutionary enough to earn a Nobel Prize, though controversially, Bell herself was excluded. And yet, the nickname lingered in memory. Our first alien was a dead star. A decade later, another signal would seize the world's imagination. On the 15th of August 1977, the Big Ear radio telescope in Ohio recorded something extraordinary. For 72 seconds, it captured a strong narrowband transmission near the hydrogen line, exactly where Cocconi and Morrison had predicted civilizations might choose to speak. Astronomer Jerry Eman, reviewing the computer printout, was so astonished that he scrawled a single word in the margin: "Wow." The wow signal became legend. It had all the hallmarks of something artificial, focused, powerful, precisely aligned with hydrogen's cosmic frequency. And then, just as suddenly, it was gone. No repeat, no echo, no follow-up detection despite decades of searching. Some proposed it was a reflection of Earth-based transmissions off space debris. Others suggested a passing comet cloud emitting radio noise. None of the explanations fit perfectly, and so the wow signal remains what it has always been, a haunting question mark, a single word scrawled in the margins of cosmic silence. These episodes left scars on the young field of SETI. They taught caution. Extraordinary claims demanded extraordinary evidence. A protocol emerged. Every potential signal must be verified by multiple observatories, in multiple locations, before it could be considered real. False alarms could not be allowed to spark panic or worse, ridicule. To quantify the stakes, scientists created the Rio scale, a kind of Richter scale for alien contact. A candidate signal that was interesting but uncertain might rate a 2 or 3. A confirmed artificial message from an advanced civilization would be a 9 or 10, the kind of discovery that would redefine humanity overnight. But perhaps the strangest impact came not from science but from culture. For decades, fiction had rehearsed the drama of first contact. In 1938, Orson Welles' radio adaptation of War of the Worlds convinced some listeners that Martians had invaded New Jersey, sparking panic in the streets. In later years, films like Close Encounters of the Third Kind, Contact, and Arrival painted the experience of contact as sudden, transformative, terrifying, or redemptive. These stories shaped public expectations. If aliens were to speak, it would be loud, obvious, impossible to miss. Yet the real contact candidates were quiet things, strange pulses in the night sky, fleeting whispers across a narrow band of frequencies. Easy to miss, easy to doubt. The irony was clear. Science fiction had taught us to expect thunder, but nature spoke in whispers. And when whispers came, they were often drowned by our own eagerness to assign them meaning. Human beings are wired for pattern recognition. We find faces in clouds, animals in the stars, intention in the wind. It is both our gift and our curse. For SETI, it meant a constant struggle, not just against the silence of the universe, but against the tricks of our own minds. Still, even false alarms mattered. The pulsar revealed new frontiers of astrophysics. The WOW signal, though unresolved, galvanized public interest in SETI for decades. And in every case, the lesson was the same. The universe is stranger than we think, and not everything strange is a message. But that knowledge carried its own kind of thrill, because if the universe could produce such wonders accidentally, what might it produce intentionally? These first false alarms forced scientists to ask harder questions. How would we know, truly know, if a signal was artificial? What safeguards would prevent us from mistaking natural phenomena for intelligence or dismissing intelligence as mere noise? The boundary between discovery and delusion was razor thin, and crossing it too soon could doom the credibility of the field. But failing to cross it might mean missing the most important discovery in human history. By the late 20th century, SETI had become a discipline defined by this tension, always listening, always cautious, never certain. We rehearsed our protocols, refined our instruments, and waited. For decades, the silence held. But the lessons of LGM-1 and the WOW signal lingered like ghosts in the machine. Every time a telescope recorded something unusual, scientists asked themselves the same uneasy question. Is this another false alarm, or is this finally the reply? On the night of July 1st, 2025, the Atlas telescope in Chile was doing what it always did, quietly scanning the sky for rocks that might kill us. The Asteroid Terrestrial Impact Last Alert system was built for vigilance, not wonder. Its job was to catalogue faint streaks of light, to measure orbits, to calculate probabilities of disaster. Every 30 seconds, its cameras captured another slice of the heavens, feeding data into an automated pipeline that could flag anything unusual. Usually, the alerts meant small asteroids, harmless wanderers passing Earth at a safe distance. But that night, the algorithms found something different. At 3:42 UTC, in the constellation Microscopium, a point of light was moving far too fast. It crossed the star field at nearly 3 arcseconds per hour, swift enough to betray an interloper. Within hours, Atlas confirmed what its own designers had scarcely dared to imagine. This object was not bound to the Sunday. Its orbit was hyperbolic, eccentricity greater than 1, which meant only one thing. It had come from outside the solar system. By dawn, the news rippled through the astronomical community. Pan Stars in Hawaii confirmed it. Zwicky Transient Facility in California confirmed it. The Minor Planet Center in Cambridge, Massachusetts gave it a name, 3I divided by Atlas. The third interstellar object ever found, after Oumuamua in 2017 and Borisov in 2019. But this one was different. Oumuamua had been strange enough, an elongated shard tumbling end over end, accelerating slightly in ways comets should not. Borisov, by contrast, had looked and behaved like a textbook comet, a cosmic reassurance that interstellar visitors could be ordinary. But 3I divided by Atlas defied easy categories. Its brightness varied with eerie precision, as though it were rotating not chaotically, like a rock, but in a deliberate, almost mechanical rhythm. Its trajectory was steeper, its approach faster, its light curve harder to explain away. Telescopes swung toward it worldwide. The European Southern Observatory's Very Large Telescope in Chile caught its first spectra. Keck, in Hawaii, applied adaptive optics. Even Hubble bent its schedule, stealing precious orbits to watch the newcomer. Each observation deepened the mystery. Its spectrum was clean, too clean, with faint traces of gases, but none of the chaotic signatures expected from cometary outgassing. Its colors didn't match asteroids or comets, either too red for one, too strange for the other. Then came the radar. Goldstone, part of NASA's Deep Space Network, bounced powerful pulses off 3I divided by Atlas. The echoes that returned were not rough and scattered, the way natural rocks reflect. Instead, they were sharp, mirror-like, as if the object had smooth surfaces angled with geometric precision. Smoothness is rare in nature. Precision angles are rarer still. By mid-July, the object had earned a nickname whispered across observatories. The reply, not official, but resonant. Because behind the measurements, a deeper question was already stirring. For over a century, humanity had leaked its signals into space, television, radar, deliberate messages like the Arecibo broadcast. If anyone had been listening, they would have had decades to prepare. Could 3I divided by Atlas be the answer? Scientists hesitated. Caution was a survival instinct in SETI. After all, they had been fooled before pulsars. The WOW signal, comet reflections. But this time the evidence felt heavier, stranger, an object from interstellar space, moving with a trajectory that suggested intent, bigger, brighter, more controlled than its predecessors, a visitor not like any other. And beyond the quiet halls of academia, the public imagination was already racing. Within days of the discovery, social media christened it with names: The Messenger, The Answer, Visitor 1. News anchors spoke of it in tones halfway between wonder and dread. For every scientist urging restraint, there were 1,000 voices online declaring certainty. The aliens had arrived. Governments noticed too. Behind closed doors, defense ministries circulated memos. If this was artificial, was it a probe, a scout, a weapon? The Planetary Defense Coordination Office, created after the 2013 Chelyabinsk impact to monitor space threats, now faced an entirely new kind of hazard. Not a rock falling from the sky, but something that could maneuver, that might be under control. What protocols existed for that? None. Yet amid the fear, something else stirred exhilaration. After generations of waiting, after decades of silence, the thought crept in that perhaps the universe had finally spoken back. Perhaps this was not chance, but an answer. Not the roar of a warship, but the patient arrival of a message. And if that were true, then 3I divided by Atlas was not just an object. It was a reply across the abyss of time and space, arriving at the very moment our own species had grown noisy enough to be noticed. The first answer, perhaps, or the first sign that the silence had never been silence at all. Astronomers are used to strangeness. They have catalogued galaxies colliding, black holes consuming stars, supernovae brighter than entire galaxies. But the closer they looked at 3I divided by Atlas, the more unsettling it became. This was strangeness of a different order, not the chaos of nature, but the suggestion of something deliberate. The first hint came from photometry. As the object rotated, its brightness rose and fell with uncanny regularity. Most asteroids tumble chaotically, like stones skipping end over end. Their brightness curves wobble, reflecting scars of countless collisions. But 3I divided by Atlas showed a near-perfect rhythm, a major cycle of about 3 hours, overlaid with smaller oscillations. It was as if the object were keeping time, as though its orientation was managed rather than random. Controlled rotation is not something the cosmos usually produces by accident. Then came spectroscopy. The European Southern Observatory reported faint gas emissions, but not the kind seen in comets. No water vapor coma sparkling in sunlight, no ghostly tales of carbon monoxide. Instead, its spectrum was muted, dominated by reflected sunlight. Its surface was too red for a rocky asteroid, yet too clean to match organic-rich comets. Some lines hinted at exotic carbon compounds, others at metallic films, materials that seemed, if not impossible, then at least highly unusual in nature. Some researchers whispered the word engineered. Radar painted an even stranger picture. Goldstone's powerful S-band pulses returned, not the fuzzy scatter of rough rock but sharp, specular reflections, as though bouncing off flat, mirror-like panels. Its radar cross-section was smaller than expected for its brightness, suggesting either a geometry designed to scatter radio in unusual ways or a deliberate use of thin, reflective surfaces. Nature rarely makes mirrors. Engineering often does. The James Webb Space Telescope turned its infrared eye toward the visitor and revealed puzzles even stranger. Its thermal signature did not follow the simple inverse square law. Objects closer to the sun heat predictably, their temperatures rising and falling with distance. But 3I divided by Atlas seemed to regulate itself, holding steady plateaus, cooling more slowly than it should. Embedded in its infrared glow were narrow spikes, sharp flashes of heat that appeared and vanished as the object rotated, like glimpses of surfaces designed to reflect or emit energy at precise wavelengths. Scientists struggled for analogies: thin films, metamaterials, coatings tuned to manage heat in ways unknown to earthly engineering. Whatever it was, it behaved more like technology than geology. If the physical strangeness unsettled scientists, the cultural reaction bordered on hysteria. Leaks spread quickly. Amateur astronomers built websites tracking every observation. Forums filled with speculation. Some insisted it was a derelict spacecraft, drifting for millennia. Others imagined it as a probe, an ambassador, even a warning buoy. Skeptics countered with natural explanations: an unusually thin shard from a shattered comet, a piece of debris from a stellar collision, something exotic but still natural. The debate raged, but the facts piled up like kindling. Even the way the object moved invited suspicion. Subtle deviations in its orbit suggested tiny, persistent accelerations. Not random, but coherent, always aligned sunward or anti-sunward, as though radiation pressure were nudging it. That would make sense for a thin, light surface like a solar sail, but the measured reflectivity was too low. Something else was happening, something that hinted at active control. To many scientists, these mysteries felt familiar. Oumuamua had also shown unexplained accelerations. In 2018, a team published a paper suggesting it might have been pushed by sunlight like a sail. The idea was controversial but not dismissed. Now, with 3I divided by Atlas, the parallels were harder to ignore. Where one anomaly could be coincidence, two began to look like a pattern. And then there was the silence, or rather, the lack of it. Natural objects make no sound beyond reflected light and scattered radio. But by mid-July, as observatories around the world coordinated their tracking, whispers began to emerge of something else. At 1,420 megahertzes, near the hydrogen line, a faint, narrowband tone appeared. Faint, but real, consistent, moving in lockstep with the object's Doppler shift. If true, this was more than strangeness. It was a voice, a whisper in the hydrogen corridor, the very place Cocconi and Morrison had said civilizations would choose to speak. And suddenly, the entire context of 3I divided by Atlas shifted. No longer just an exotic shard or engineered sail. It might be what humanity had been waiting for across a century of silence, the first reply. On the 15th of July, 2025, just 2 weeks after its discovery, astronomers pointed their antennas toward 334I divided by Atlas and heard something that made the air in every control room go still. It was faint, fragile, almost like the sound of a flute in a storm. A narrowband signal, sitting at 1,420.4 megahertz, just a hair's breadth away from the hydrogen line, the most important frequency in the universe. The first detections came from the Very Large Array in New Mexico, then from Green Bank in West Virginia. Hours later, from FAST in China, the largest radio dish in the world. Independent, scattered observatories across the planet, each one confirming what the others had already whispered. The signal was real. It wasn't an artifact, wasn't a glitch, wasn't a stray microwave oven opening in the staff kitchen. It was coming from the same patch of sky as 3i divided by Atlas, shifting in frequency exactly as the object's motion predicted. Skepticism, of course, was immediate. Radio astronomy has always been plagued by interference. Satellites chatter across the spectrum. Cell towers leak harmonics. Even the hum of electronics can masquerade as cosmic music. But this signal passed every test. It vanished when telescopes looked away from 3i divided by Atlas. It drifted in frequency with its Doppler shift, perfectly aligned with the object's orbit. It was stable to an extraordinary degree, like it was anchored to an atomic clock. Natural phenomena can mimic many things, but not that. Not frequency stability measured in billionths of a second. Not a whisper so perfectly placed in the one band of the spectrum humanity had declared as the cosmic meeting place. And so, for the first time in history, the SETI protocols written in anticipation of this very moment were activated. Reports were filed. Data was shared. The International Academy of Astronautics issued urgent communiques to governments, urging restraint, verification, silence. But the world was already finding out. Leaks were inevitable. A junior researcher at Greenbank posted a cryptic message on social media. "Hydrogen sings tonight." Within hours, screenshots of spectrograms began circulating in online forums. The hashtag number "the reply" trended worldwide. Amateur radio enthusiasts, equipped with cheap software-defined receivers, confirmed they could detect faint traces of the signal themselves. This wasn't a secret that could be contained. The public reaction was volcanic. YouTube filled with videos titled, "Proof, Aliens Answered Our Call," and the message at 1,420 megahertzes. Memes spread faster than official press releases. Some called it the messenger, others, more ominously, the beacon. For a species raised on science fiction, the narrative was irresistible. After a century of silence, the universe had answered. Scientists, however, moved with painful caution. The first rule of extraordinary claims is doubt. Was it plasma? Was it a maser in space? Was it some quirk of the solar wind interacting with 3i divided by Atlas's surface? But the frequency choice was damning. Why broadcast so close to hydrogen's quiet line, unless you wanted to be heard? Meanwhile, governments reacted in silence. Internal memos leaked later showed how quickly the mood turned from curiosity to unease. The Planetary Defense Coordination Office, created to track asteroids, suddenly faced an unprecedented category, an interstellar object that could maneuver, and now appeared to be transmitting. What if this wasn't a relic? What if it was active, alive in some way, or worse, controlled? At the United Nations, the Office for Outer Space Affairs dusted off old contingency documents that had never been meant for real use. They were designed for false alarms, for academic speculation, not for the moment when the sky itself began to whisper back. Yet perhaps the most remarkable detail was this. The signal said nothing. No modulation, no complexity. Just a pure, unwavering tone. Like a dial tone. Like the universe was picking up the receiver and waiting for us to speak. And that, perhaps, was the most unsettling truth of all. Humanity had been broadcasting for over a century TV shows, baseball games, deliberate messages like the Arecibo signal. Now, at last, something had replied. But the reply was not a story, not a greeting, not a threat. It was a single note, held steady. A cosmic way of saying, "We hear you. Now, will you answer?" If 3i divided by Atlas had been the only visitor, it might have remained an anomaly, a singular curiosity like Oumuamua, destined for decades of debate. But the universe was not finished. 3 weeks later, the sky began to fill with companions. On July 22, 2025, the Catalina Sky Survey flagged another fast-moving object, this one christened 4i. 2 days later, Linear reported 5i. By August, amateur astronomers with backyard telescopes were submitting discoveries confirmed by professional observatories. Soon, a catalogue was forming. 6i, 7i, 8i, an unsettling parade of interstellar visitors. And unlike Oumuamua or Borisov, these were not random wanderers. Their approach vectors clustered within a narrow cone of the sky, all pointing back toward the constellation Lyra. Their perihelia, their closest approach to the Sun, threaded the very orbital zone Earth occupies. The odds of such coordination occurring naturally were infinitesimal. A team at Queen's University Belfast calculated the probability: less than 1 in 50 million. These were not accidents, these were trajectories aimed. Their shapes deepened the unease. Where 3I divided by Atlas appeared like a thin rotating panel, 4I's light curve suggested something needle-like, 20 times longer than it was wide, spinning in a strangely stable pattern. 5. I looked fractured, tumbling with the complexity of a broken shard. 6. I behaved like a flake of something flexible, rippling as it turned. These were not the rough spheres and jagged fragments nature usually produced. They were thin, extreme, almost delicate, as though optimized for travel across impossible distances. And then, each one began to sing. Not all at the same pitch, not all in the same way, but all near the waterhole of the spectrum. 3I divided by Atlas continued its steady tone near 1420.4 megahertzes. 4. I broadcast at 1420.6, with faint amplitude modulation. 5. I pulsed in bursts across multiple frequencies. 6I's signal was the strangest of all, complex variations in frequency and timing, as though carrying encoded information. The effect was unmistakable. Alone, each signal could perhaps be dismissed. Together, they resembled instruments in an orchestra, different voices, coordinated across millions of kilometers. To Earth's radio astronomers, it felt less like nature and more like strategy. A distributed communication system, redundancy built in, a chorus ensuring their message could not be missed. The staging hypothesis emerged quickly. Dr. Elena Vasquez of Arecibo proposed it first. These were not random interstellar debris, but a carefully orchestrated sequence. A flotilla, a wave designed for visibility. If one probe were dismissed as natural, another would take its place. If one signal were overlooked, another would be clearer. It was communication by saturation, a cosmic failsafe. And the timing was damning. When astronomers backtracked the launch windows, these objects would have needed to reach our solar system by 2025. A pattern emerged. If 3I had been dispatched from 50 light-years away, it would have left around 1975, just as Earth's most powerful television transmitters and radar systems were filling space with unmistakable artificial noise. 4. I aligned with the Cold War radar boom. 5. I matched the rise of satellite communications. It was as if someone had been listening, decade by decade, and launching replies in sequence. The realization spread slowly at first, then like wildfire. These were not messengers chosen at random. They were responses to us. The radio signatures added fuel to the fire. Some of the transmissions echoed patterns from the 1974 Arecibo message binary sequences, prime numbers, but extended them with variations. Not mimicry, but expansion, as though saying, "We heard you, we understood. Here is more." In the professional community, caution remained the official posture. Press releases emphasized unusual but natural possibilities, fragments of exotic comets, unstudied forms of interstellar debris. But in the labs and observatories, the private conversations shifted tone. No one could ignore that the sky was suddenly populated with objects that looked nothing like asteroids, moved nothing like comets, and spoke in the universal mathematics humanity had chosen as its first greeting. The public had no such restraint. Hashtags multiplied. Number visitors, number the fleet, number the reply. Artists depicted elegant sails drifting through the void. Conspiracy forums warned of invasion. Spiritual movements declared them heralds, angels of a galactic awakening. Every telescope open to the public was swamped with visitors, people waiting for a glimpse of distant dots that now carried the weight of humanity's imagination. And still, the signals grew. By late summer, multiple objects transmitted in unison, brief bursts, synchronized across millions of kilometers, like a chorus singing the same note. It was the most chilling detail of all. The visitors were not only speaking to us, they were speaking to each other, coordinated, connected, alive, in the way fleets and communities are alive. By September, 15 confirmed interstellar objects were catalogued, dozens more candidates awaiting confirmation. The solar system, once empty but for comets and asteroids, now hosted a gathering. Not random, not chaotic, but orchestrated. The message was no longer whether someone was trying to contact Earth. The message was clear: if only we dared to admit it, we are not alone, and we have been heard. The mathematics were unavoidable, and mathematics is merciless. By autumn of 2025, astronomers had done the calculations again and again, running simulations with supercomputers, checking against every database of signals and trajectories. The conclusion unsettled even the skeptics. If these visitors truly originated 50 or so light-years away, then they would have needed to detect Earth's transmissions decades ago in order to time their arrival for now, which raised the most dangerous question of all. When could they have known we were here? Dr. James Chen at MIT's Haystack Observatory took on the task of reconstructing Earth's electromagnetic footprint. It was not simple. Every transmitter, military radars, television towers, planetary experiments had different power levels, different beam shapes, different frequencies. The radio bubble was not a perfect sphere of noise, but a ragged, pulsing sphere of uneven volume. Chen's team mapped it decade by decade, watching it expand at light speed, reaching new stars year after year. The early decades of radio, the 1,920 seconds and 1,930 seconds, were too faint to matter. Our first television broadcasts in the 1,940 seconds and 50 seconds carried farther, but still only a few light years. Yet by the 1,960 seconds, something changed. The Cold War had filled the sky with massive radar systems, pulsing megawatts of power into the heavens. Planetary radar experiments, especially from Arecibo after 1963, were brighter still. Chen calculated that an alien telescope with sensitivity comparable to our own could have noticed us clearly by the mid-1970 seconds. In other words, just when the first probes 3I divided by Atlas among them would have needed to depart to reach us now. The geometry made the case stronger. When astronomers traced the back trajectories of the incoming flotilla, they found something eerie. Their lines of origin passed close to specific stars that would have been in the path of Earth's loudest transmissions. HD 164595, a sun-like star 94 light-years away, would have been bathed in Arecibo's radar beams during the 1,970 seconds. Wolf 359, a red dwarf only 8 light-years distant, was perfectly aligned to receive our early television broadcasts. Tau Ceti, long a SETI favorite, matched the windows when Earth's radar swept its patch of sky. Dr. Sarah Martinez at Harvard put it bluntly: "It looks less like a coincidence and more like an answer." But skeptics resisted. Dr. Robert Hayes at the University of Arizona warned about the look elsewhere effect. With so many stars, so many transmissions, some alignments were inevitable. Humans are pattern-seeking animals. We find constellations in random stars, shapes in clouds, meaning in noise. Perhaps this was only another illusion, and yet, the timing kept haunting the data. 3I divided by Atlas, if launched around 1,975, matched our TV broadcasting peak. 4I lined up with the radar boom of the 1,960 seconds. 5I seemed to correspond with the early satellite age. The flotilla looked less like random wanderers and more like echoes, each one launched in response to a chapter of Earth's growing noise. The transmissions themselves carried hints. Some of the narrowband pulses from the visitors echoed the structure of the 1,974 Arecibo message. That message had shown numbers 1 through 10 inches binary, the atomic numbers of DNA elements, a crude pictograph of a human, and a diagram of the solar system. Now, faint in the signals of 3I and 4I, astronomers found sequences that resembled primes, but not just the simple primes we sent. These extended into deeper patterns, twin primes, Sophie-Germain primes, sequences humanity had only begun to explore in modern mathematics. It was as if the visitors were replying in kind. "We received your numbers, here are ours. We understand," and more. The effect was electrifying. To some, it was confirmation that we were truly in dialogue, that another intelligence had not only heard us, but taken the time to answer in the one language no species could mistake, mathematics. To others, it was merely coincidence layered with human projection, an elaborate case of seeing faces in the stars. The debates filled journals and conferences, with tempers running hot. Yet the statistical analyses kept strengthening the case. Chen's team ran Monte Carlo simulations with randomized data. Martinez's group compared alignments across thousands of hypothetical star systems, again and again. The correlations exceeded chance. The odds of such timing being random slipped into the realm of 1 in 10,000, then 1 in 100,000, not proof but uncomfortably close. The term that emerged was the echo hypothesis. Earth had shouted into the dark television signals, radar pings, the Arecibo message. And now, after the appropriate delay, the cosmos had sent echoes back. Not just one, but many. Not faint whispers, but coordinated arrivals. If true, it was staggering. It meant the visitors were not merely wanderers passing by. They were listeners. They had heard us, understood us, and chosen to reveal themselves in the most undeniable way. By arriving. And yet, perhaps the most unsettling realization was this. If they had been listening since the 1,960 seconds, they had been listening for a long time. Long enough to know us better than we knew them. Long enough to hear not just our greetings, but our arguments, our wars, our laughter, our entire species, exposed in a bubble of radio. The question was no longer whether they had heard us. It was simpler, sharper, and infinitely more frightening. What did they think of what they heard? By October 2025, after months of telescopes trained on a procession of strangers, the picture of 3I divided by Atlas had coalesced into something that refused to fit tidy categories. It was a thing composed of measurements and absences, a silhouette built from echoes, radar returns, spectrographs, thermal curves, and each new dataset made the object more intriguing and more unnerving. Measured end to end, 3I divided by Atlas stretched roughly 200 meters. Its width sat near 20 meters. Radar observations suggested a thickness under 2 meters in many places. Imagine a wafer in space, long, thin, and improbably flat for anything that had been formed by collisions and eons of tumbling. The object's aspect ratio exceeded 10:1. Where natural rubble tends toward the squat and battered, this visitor favored planes, edges, and facets. Its rotation told another story. Instead of the chaotic tumble you'd expect from a battered fragment, Atlas held a stable spin axis. Photometric measurements showed a dominant period about 7.3 hours, remarkably consistent across weeks of observation. Embedded within that primary rhythm were secondary oscillations, small, repeatable modulations that suggested articulated motion, not random wobble. The behavior was eerily deliberate, as if tiny attitude control forces were nudging its orientation to precise celestial coordinates. When those adjustments correlated with solar illumination angles, the implication deepened. The object seemed to be optimizing exposure, perhaps to collect or manage solar energy or to present different faces for observation. Spectroscopy added odd texture to the mystery. Its reflectance spectrum refused to match familiar asteroid or comet classes. Slopes and absorption bands hinted at complex carbon allotropes, perhaps polymers or engineered organics, mixed with traces of boron nitride-like features and patterned metallic dopants. The words researchers used shifted from unusual to suggestive. Dr. Abraham Lowe at Harvard, an engineer turned astromaterials analyst, described the signature as consistent with materials treated at the nanoscale, a phrase heavy with implication. Natural processes can produce strange chemistry, yes, but patterned doping and layered coatings are the hallmarks of design. Thermal behavior confounded expectations even further. Under direct view of the James Webb Space Telescope and other infrared facilities, Atlas did not warm and cool like a passive rock. Its temperature evolution showed plateaus regions where temperature barely varied despite changing solar distance. Embedded in that thermal baseline were spikes, narrow, intense flashes of infrared emission that recurred as the object rotated. The timing and spectral width of those spikes were consistent with thin films that could selectively reflect or emit at specific wavelengths. In short, active thermal management, perhaps through micromechanical louvers or metamaterial coatings whose emissivity could be switched or tuned. Then there were the accelerations. Careful orbital fits revealed small but persistent non-gravitational accelerations, tiny thrusts that accumulated into measurable trajectory deviations. They were always aligned roughly sunward or anti-sunward, not random perturbations. The magnitudes were minute orders of magnitude weaker than Earth's gravity, yet over time, they altered course enough that purely gravitational models failed to predict Atlas's path. Radiation pressure on a thin sail could explain some of the effect, but only if reflectivity were far higher than the measured albedo. Conversely, outgassing volatile materials sublimating could produce thrust, but the detected gaseous emissions were far too meager to account for the observed accelerations. The arithmetic simply didn't balance. Radio observations remained the single most provocative line of evidence. The primary carrier at to 1,424 MHz had morphed from an unmodulated beacon into structured transmissions. Prime number sequences 2, 3, 5, 7, 11, 13, 17, 19 were broadcast in clear groups, then repeated and compounded into more sophisticated mathematical progressions. The primes were not random, they were delivered with timing, exactness, and harmonics that betrayed incredibly stable oscillators, the sort of frequency control usually associated with atomic clocks. Over time, harmonics and sidebands appeared at precise mathematical intervals, suggesting intentional encoding and an understanding of information theory. For many SETI researchers, prime sequences were the lingua franca of first contact, simple enough that any intelligence could recognize intentionality, yet deep enough to demonstrate mathematical concept. But Atlas and its companions went further, introducing numerical patterns that correlated with known human encodings like the 1974 Arecibo layout, then diverging in ways that read like an elaboration rather than a copy. Nearby fragments complicated the picture. Around Atlas, smaller companion pieces catalogued as 3IA through 3IF moved in loose formation. Their light curves and radar echoes mirrored the main object's quirks: specular reflections, controlled attitude hints, and faint but consistent radio carriers. The formation suggested systems engineering, multiple nodes working together, relays or calibration mirrors perhaps, extending the hypothesis from single probe to distributed system. The very long baseline interferometry networks detected microcourse corrections in some companions, tiny burns or impulse-like changes, inconsistent with random fragmentation. Formation flying at interstellar approach distances implied both coordination and purpose. The energy budget of these transmissions and maneuvers posed another riddle. The radio carriers required kilowatts of power sustained over days and weeks, substantial for an object with limited surface area for solar collection. If the transmissions were intentional communications rather than incidental leakage, the cost in energy suggested a meaningful commitment from whoever built these things. Engineers back-calculated what internal power reserves and collection areas would be necessary. Their results hinted at either very efficient energy systems, access to exotic materials with superior photovoltaic properties, or a design that could harvest energy across electromagnetic bands with unheard-of efficiency. Scientists framed three competing hypotheses, each with its predictive tests and stubborn adherents. The first, the engineered light sail or probe hypothesis, treated Atlas as an autonomous artifact, an emissary or relay optimized for longevity and communicative reach. It fit many pieces: thin geometry, attitude control, thermal management, radio carriers. The second, exotic natural fragment, posited that Atlas was a product of a rare astrophysical event, a fragment from a tidal disruption, a shard formed under conditions that produced thin sheet morphologies and unexplored chemistries. The third, a hybrid technobiotic hypothesis, floated the unsettling possibility of materials that blurred the line between life and machine, self-maintaining, adaptive matter that used biological-like processes to repair and respond. What kept the field honest was methodical skepticism. Each bold claim required cross-confirmation. Thermal plateaus had to be reproducible across instruments. Radar specular returns needed to be consistent from multiple baselines. The prime sequences had to survive blind analysis and attempts at packet injection to rule out algorithmic hallucination. Research teams practiced adversarial collaboration groups with opposed priors, exchanging datasets and attempting to break each other's conclusions. The history of science demanded nothing less. After Oumuamua's debates, the community had learned how fast consensus could fracture under public pressure and how much credibility depended on replicable, conservative analysis. Still, even conservative language carried weighty implications. Atlas exhibits properties difficult to explain through known natural processes. One consensus statement read, "Artificial origins cannot be excluded. Further observations and analysis are required. Those 9 tidy words masked a cultural rupture. For the first time, humanity's dominant scientific institutions were seriously entertaining the possibility that some visitors were engineered. The knife edge between proof and pareidolia had never been sharper, nor had the world ever watched so closely for which way the blade would fall. Science is not swayed by drama, not officially. The laws of peer review, of careful language, of restrained conclusions, demand understatement even when the data screams otherwise. Yet by late 2025, the statistics surrounding the flotilla of interstellar visitors left even the most sober astronomers shaken. Numbers have no imagination, and the numbers said something extraordinary: the unlikelihood of multiples. The first improbability was simple: the count. Before 2017, not a single interstellar object had ever been observed. Astronomers had speculated for decades that fragments from other systems must occasionally pass through ours, but the expectation was one every few centuries, maybe one in a millennium. Then came Oumuamua, then Borisov, both close enough together to rattle assumptions, but still possibly coincidence. But in 2025, within a single season, humanity had recorded more than a dozen. The odds were brutal. Dr. Katarina Holm of the European Southern Observatory ran the models. Given current detection sensitivity, the probability of cataloguing 15 interstellar objects in just 3 months, by pure chance, was less than 1 inch 10 circumflex 15, 1,000,000,000,000 to 1 shot. Even if astronomers had underestimated the background population by orders of magnitude, the clustering in both time and direction made coincidence essentially impossible. Directionality, a finger pointed at Earth. The second improbability lay in the sky maps. When plotted in galactic coordinates, the trajectories of the visitors did not scatter randomly like cosmic dice. They converged, within narrow tolerances, on the vicinity of Earth's orbit. Random objects should have perihelia spread across millions of kilometers of solar real estate. Yet over half of the flotilla aimed for approach distances within a tiny sliver of orbital space, the very zone Earth occupies. Statistically, it was like throwing 100 darts blindfolded and watching them all cluster around a single bullseye. Dr. Omar Anwar of the University of Cape Town calculated the chance alignment: less than 1 in 50 million if natural. Another team at JPL refined the figure to 1 in 100 million. Both agreed the evidence pointed to targeting, timing, and the echo hypothesis. The third improbability was temporal. If these objects had originated from nearby stars, say 30 to 60 light-years distant, then their departure windows placed their launches somewhere between the 1,960 seconds and the early 1,980 seconds. That was precisely when Earth's electromagnetic leakage reached its loudest. Cold War radars, Apollo's transmissions, the Arecibo message of 1974. Simulations showed that if a civilization had detected our signals in that era and immediately dispatched probes, they would have arrived, now, 2025, within months of each other, within the window when Earth's telescopes were finally powerful enough to notice. The coincidence was staggering. Dr. Elena Vasquez called it a synchrony that strains the word coincidence beyond breaking. Statistical consensus. By October, 3 independent teams had published Bayesian analyses, each weighing the natural versus artificial hypotheses. The prior probability that interstellar objects should cluster in number, direction, and timing like this was vanishingly small. When combined, the posterior odds favored deliberate origin by factors ranging from 10,000 to 1 to 100,000 to 1. These were not the odds of certainty, but in the world of science, where 5 sigma detections decide the existence of new particles, these were odds that screamed, "Pay attention." Public reaction. Numbers as ammunition. Outside the journals, the statistics became weapons in culture wars. Advocates of the visitor's hypothesis wielded them like banners. 1 in a trillion, open your eyes. Skeptics clung to the history of false alarms, warning that extraordinary odds still could hide overlooked natural mechanisms. On talk shows, politicians quoted Bayesian posterior probabilities without knowing what they meant. Memes flooded the internet. Graphs of improbable alignments turned into artwork. Young people tattooed 10 circumflex 15, 1 on their arms. Numbers became symbols. The cold language of statistics transformed into something almost religious. The uneasy conclusion. But for scientists themselves, the unease was sharper. Numbers had forced them into a corner. No matter how cautious the wording, no matter how many caveats were layered into reports, the truth whispered behind every calculation was the same. If the data is real and it has survived every attempt at falsification, then nature alone is not enough. Something has aimed, something has planned, something has heard us. The human ear is tuned to hear meaning in sound where none exists. Voices in the wind, music in the crackle of fire. Radio astronomers know this weakness well, and so their discipline demands a cold, mathematical ear. A narrowband tone at 1420 MHz can tempt imagination, but science asks, is it structured or is it noise? By November 2025, that question had become the defining obsession of dozens of observatories. The flotilla's signals were being recorded continuously, terabytes each night, data streams routed into supercomputers at Berkeley, Jodrell Bank, and Shanghai. Algorithms stripped away interference from satellites and terrestrial sources. Doppler drift corrections were applied so that the signals could be frozen, as if the probes were sitting motionless against the stars. And then, patterns began to emerge, primes and beyond. The first and simplest structure was unmistakable: sequences of prime numbers, 2 pulses, then 3, then 5, 7, 11. Broadcast as timed bursts in the carrier amplitude. That much alone was enough to raise eyebrows. Prime sequences are vanishingly unlikely to occur naturally. They are, as Carl Sagan once said, the handwriting of mathematics itself. But it did not stop there. Some probes transmitted paired primes, twin primes like 11, 13, 17, 19, 29, 31. Others extended into exotic classes, Sophie-Germain primes, Mersenne primes concepts, esoteric even among human mathematicians. The implication was unnerving. Whoever was transmitting not only understood primes, but knew the branches of number theory we had spent centuries unraveling. Grids in time. Beyond the primes, spectrograms revealed something subtler. The bursts were not random in spacing. When plotted in 2 dimensions, time on one axis, frequency drift on the other, they fell into lattices, grids, rectangles. Some resembled the 23 times 73 grid used in the Arecibo message. Others suggested different ratios, as though the probes were presenting multiple canvases, multiple pages of information. Dr. Reena Kapoor at Caltech was the first to say aloud what others whispered. They are sending diagrams, echoes of Arecibo. It was in those grids that humanity recognized itself. Within the pulse matrices of 3I divided by Atlas, analysts discerned arrangements eerily similar to the binary pictographs of 1974, a ladder-like shape suggesting DNA, a central figure resembling a biped, dots in a line evocative of planets around a star, not identical, but transformed, elaborated like a teacher, taking a child's scrawl and rewriting it with clarity. To some, this was proof of reply. They had heard Arecibo, understood it, and were sending back an answer. To others, it was dangerous projection. Our minds are tuned to see faces in clouds and meaning in randomness. Were we decoding intelligence or hallucinating? Statistical confidence. To test this, the SETI community turned to blind analysis. Teams were given randomized slices of signal data, with and without the supposed patterns, without being told which was which. Again and again, independent groups detected non-random structure at confidence levels exceeding 6 sigma, well beyond chance. Whatever the flotilla was broadcasting, it was not noise. The Rio scale, humanity's metric for the credibility of extraterrestrial contact, had hovered around 3 or 4 for earlier anomalies. With these detections, experts began to place the signals at Rio 7, strong evidence, with potential to be confirmed communication. No event in history had ever scored so high. Cultural shockwaves. When the first peer-reviewed papers were released, cautious, hedged, but unmistakable, the cultural shock was immediate. Headlines screamed, "Math from the stars and aliens answer our message." Religious leaders issued statements ranging from awe to denial. Stock markets shuddered with uncertainty. For the public, the patterns were electrifying. News broadcasts displayed binary matrices as though they were sacred glyphs. Online forums filled with amateur decoders. Some insisted they saw entire blueprints for technologies. Others saw philosophical symbols. A few conspiracists claimed governments were suppressing the true message, that the public was being drip-fed only what elites wanted them to see. But beneath the noise of public imagination, one fact was clear. After a century of listening, humanity was no longer staring into silence. We were staring at structure, at order, at the first genuine whisper of intelligence across the stars. The question was, no longer is there a signal. It was, what are they trying to tell us? The first patterns had been tantalizing primes, grids, echoes of Arecibo, but by December 2025, attention shifted to something subtler. Hidden within the narrowband tones at 1,420 MHz, researchers began to see variations that looked less like mathematics displayed and more like a language encoded, a carrier with secrets. At first, the transmission seemed like simple on-off pulses, but with higher resolution sampling nanosecond precision from the Green Bank telescope and the 500-meter aperture in China, analysts uncovered delicate fluctuations in phase and polarization. These were not artifacts of noise. They were intentional modulations riding on the hydrogen line carrier, as if the steady beacon were merely a dial tone and the real content was buried within. Dr. Samuel Duarte at Berkeley SETI called it carrier concealment. Just as human radio systems hide information inside modulation schemes FM, AM, phase shift keying, the visitors appeared to be using the hydrogen frequency as a universal header, while tucking their true message within microscopic shifts too fine for casual detection. The hydrogen atom as alphabet. Decoding began with the obvious, hydrogen itself. The 21-centimeter spin flip line was not just a meeting place in the spectrum, it was a universal constant. And in the flotilla's signals, modulations echoed hydrogen's properties, spin states, hyperfine transitions, frequency ratios derived from fundamental constants. It was as if the aliens had built an alphabet of physics, each letter defined not by arbitrary symbols but by ratios any civilization would know. The fine structure constant, Planck's constant, the electron-to-proton mass ratio. Instead of vowels and consonants, the hydrogen code used nature's deepest invariants. Pages of information. Once decoded into this alphabet, the pulses began to reveal structure. Grids expanded into complex diagrams, lattice-like pages that seemed to depict molecules, orbitals, energy levels. One page resembled a schematic of amino acids, another the geometry of water, a third seemed to describe nuclear transitions. The consistency was staggering. Different probes transmitted different pages, but when combined, they formed a coherent whole, like chapters of a book spread across a fleet, each reinforcing and elaborating on the others. Human reactions. The scientific world split into two camps. One, led by cautious skeptics, argued this was still projection. The diagrams might be wishful pareidolia, seeing amino acids where none existed. They pointed to the mistakes of past generations, the Martian canals, the wow signal. The other camp countered with statistics, the recurrence of fundamental constants, the repeated alignment of patterns across probes, the improbability of multiple independent signals, all producing the same structures by chance. Public discourse, however, leapt far beyond caution. Media outlets branded it the universal textbook. Religious groups declared it scripture. Activist movements called for immediate response, a message to be sent back through Arecibo's dormant dish or the Deep Space Network. The debate spilled into streets, classrooms, legislatures, governments in shadow. Meanwhile, governments studied in silence. Intelligence agencies requisitioned data streams directly from observatories. Military labs modeled whether the diagrams described not molecules, but energy systems, potential technologies, even weapons. Official statements downplayed everything, but leaks made clear the fear. What if the hydrogen code was not a greeting, but a manual? And if so, should humanity dare to read it? The most unsettling detail. But one detail chilled even the optimists. Among the pages of physics and chemistry was a recurring motif, a star system diagram. A central star, encircled by small dots. In several versions, one dot was highlighted. Cross-referenced with astronomical catalogues, it resembled not their origin wherever that was, but our own solar system. The highlighted dot was always the third from the star. Earth, it was as if the message said, "We know where you live." For more than half a century, the search for extraterrestrial intelligence had been defined by restraint. Listen, don't speak. The universe might be full of dangers, and announcing ourselves could be reckless. But by the winter of 2025, restraint was eroding. The flotilla sang every night above the world's telescopes, their signals undeniably intentional, their diagrams pointing back to us. The question became not if Earth would respond, but who would do it first. The fracture. At the official level, the United Nations convened emergency sessions. The Office for Outer Space Affairs, a bureaucratic footnote until now, suddenly became the center of history's greatest debate. Delegates argued over who had the right to reply on behalf of Earth. Some insisted only a unified global message would be legitimate. Others warned that waiting for consensus would mean paralysis. Meanwhile, private groups refused to wait. The METI International Organization, long controversial for sending unsolicited beacons, announced plans to transmit from their facility in Transylvania. Amateur radio networks buzzed with chatter about coordinated citizens' replies. Even universities discussed using planetary radars for unsanctioned experiments. The fracture was clear. The sky had spoken, and humanity could not agree on how or whether to answer the scientists' proposal. In December, an international consortium of SETI researchers released what became known as the Geneva Protocol. It recommended a cautious first step: transmit a short, purely mathematical reply. No culture, no politics, no biological details. Just numbers and constants, confirming receipt and demonstrating comprehension. We acknowledge your message, it said in essence, and we understand the language of physics. The proposal was elegant, but fragile. It required unanimous approval to feel legitimate, and unanimity was a dream Earth rarely achieved. The rogue transmission, the first reply, did not wait for protocols. On the 2nd of January 2026, at 3:17 UTC, the 70-meter dish of the Deep Space Network in Canberra, Australia, transmitted a narrowband burst at 1,420 MHz. Later investigation revealed it was the work of a coalition of engineers and scientists, sanctioned quietly by a small circle of officials who feared being left behind if another nation or group acted first. The message was short: a sequence of primes up to 101, followed by binary encodings of key physical constants: Planck's constant, the speed of light, the ratio of proton to electron mass, then a 23 times 73 grid containing a simplified response to the diagrams received: hydrogen, carbon, oxygen, nitrogen, and phosphorus, arranged as the backbone of DNA. At the bottom, a simple addition, a highlighted third planet around a yellow star, us. The transmission lasted 15 minutes. When it ended, Earth had crossed a line it could never uncross. The aftermath. News leaked within hours. Though governments denied involvement, the spectrograms of the burst were captured by amateur receivers worldwide. Protests erupted outside parliaments in Berlin, Washington, and Delhi. Some demanded accountability. Who gave you the right to speak for all of humanity? Others celebrated. At last, we've answered back. Conspiracy theories bloomed like algae in summer. Was the message really mathematical, or did it contain hidden political signals? Had the Australians slipped in national emblems? Was it a cover story for military communication with the flotilla? The waiting. The days that followed were heavy with silence. Every telescope on Earth strained to catch a change, a new pattern, a response in kind. For a week, the flotilla continued its same transmissions: steady carriers, prime bursts, the pages of the hydrogen code. But then, on January 10th, a new modulation appeared in the signal from 3I divided by Atlas. It began with the same prime sequence Earth had sent. Then came constants, repeated back like an echo. And then something new, a modulation no human had seen before. Complex, recursive, layered, expanding into structures that filled spectrograms with patterns beyond immediate recognition. Humanity had spoken, and the sky had answered back. The reply from 3I divided by Atlas was not a single voice but a layered symphony, a complexity that grew the longer Earth's receivers listened. At first, it resembled an echo. Our primes repeated back, our constants confirmed. But then, like a teacher moving past the warm-up, the signal blossomed into patterns unlike anything human mathematicians had ever seen. Recursive symmetry. The first surprise was recursion. When analysts plotted the bursts in 2 dimensions, they saw not only grids, but grids within grids. Each frame of pulses contained subframes, which contained sub-subframes, like Russian dolls of information. Zooming in did not dissolve the structure into noise. It revealed more structure, endlessly nested. This was not random. Recursive encoding is one of the hallmarks of advanced information theory, a way of packing immense content into minimal bandwidth, while ensuring redundancy and error correction. Whoever built this system had mastered communication across interstellar gulfs, universals in physics. Inside those recursive frames lay diagrams grounded in physics, ratios of spectral lines, hydrogen's 21 centimeters, carbon's 115 gigahertzes, oxygen's 60 gigahertzes, fundamentals of chemistry written in the only alphabet every civilization must share, the periodic table of the cosmos. Another frame depicted orbital mechanics, using Newton's laws expressed as ratios of mass and acceleration. A third seemed to sketch stellar evolution, a sequence of pulses corresponding to the lifetimes of stars by mass. The visitors were not merely saying, "We are here." They were building a foundation, an interspecies Rosetta Stone, starting from physics no intelligence could mistake. Echoes of biology. Then came something harder to dismiss. One grid, once decoded into binary pixels, resembled the molecular backbone of ribose and adenine. Another depicted amino acid chains. The patterns were not exact blueprints but templates, as though to say, life, yours, ours, all life emerges from these same universal shapes. Debates raged instantly. Skeptics argued that humans were imposing their own biochemistry onto ambiguous data, seeing DNA in squiggles as Percival Lowell once saw canals on Mars. But the recurrence across multiple probes, the consistency of ratios, the precision of chemical bonds, the coincidences piled too high. To many, it looked deliberate, a declaration that biology was not parochial, but cosmic. The hidden layer. The most astonishing discovery came weeks later, when a graduate student at Cambridge applied a Fourier transform to one of the longer recursive sequences. Instead of noise, she uncovered a hidden modulation subharmonics that, when reconstructed, produced three-dimensional lattice diagrams. These were not static pictures but rotationally invariant structures, as though the visitors wanted their diagrams to survive any orientation. One lattice resembled a double helix, but not exactly human DNA. Another resembled a protein fold. A third was wholly unfamiliar geometries, alien yet clearly functional, optimized by principles humans barely understood. The message was not only biology as we knew it, but biology as they knew it. The human reaction, the revelation struck the world like a hammer. News anchors called it the galactic genome. Churches split between those who declared it proof of universal creation and those who denounced it as demonic trickery. Geneticists whispered of a revolution. If the diagrams could be fully decoded, they might contain cures, enhancements, or even instructions for building life from first principles. Governments classified portions of the decoded data immediately, but leaks were inevitable. Fragments circulated online, sparking wild experiments by biohackers. Some claimed to find coherent base pair codings. Others insisted they saw viral blueprints. Fear spread that decoding too quickly might unleash something humanity could not control. The implication. Yet beneath the noise of fear and speculation, one truth pressed forward. The visitors were not merely mathematicians, they were biologists. Their first reply to Earth was not a political manifesto, not a threat, not a declaration of dominance. It was a lesson in life itself, framed in the universal constants of hydrogen and carbon. It was as if they were saying, "We know what you are. We too are alive, and here is the bridge between us." For centuries, philosophers had argued that contact with another intelligence would unite humanity, that in the face of the other, our divisions would melt away. But by early 2026, as the flotilla's signals deepened into undeniable communication, it became clear the opposite was true. The visitors had not only sent a message, they had struck at humanity's fault lines, widening every crack. The scientists' rift. Within academia, the divide was stark. One camp, led by cosmologists and biologists, saw the hydrogen code as a priceless opportunity, a galactic textbook delivered across the stars. They called for global cooperation, data sharing, and immediate open publication. "Knowledge belongs to all humanity," said Dr. Reena Kapoor at Caltech. "It is our duty to learn." The other camp urged caution. What if the message contained traps or technologies beyond our maturity? A group of Nobel laureates signed an open letter warning against reckless decoding that might unleash dangers we could not predict. "Knowledge can heal," they wrote, "but it can also poison." The rift hardened into hostility. Conferences ended in shouting matches. Joint projects dissolved. Some researchers hoarded their data, fearing misuse. Others dumped raw spectrograms online, believing secrecy itself was the greater danger. Governments in shadow. Nation-states reacted with predictable suspicion. Intelligence agencies rushed to secure observatory access, seizing raw data before it could be shared publicly. In Washington, Beijing, and Moscow, classified task forces combed through decoded diagrams for military potential. Could the visitors' biochemistry reveal new bioweapons? Could their energy lattices hint at power sources more potent than fusion? Leaked memos revealed the paranoia, fears that rival nations might make a breakthrough first and leap ahead. The flotilla became a new arms race, a cosmic Sputnik moment. Public statements urged calm and unity, but behind closed doors, secrecy reigned. Faith and fire. Religions, too, split along lines of interpretation. Some leaders embraced the contact as confirmation of universal creation, proof that life was seeded by divine intent across the stars. Sermons filled with awe. Cathedrals echoed with prayers of gratitude. Others recoiled. Entire sects declared the signals to be demonic deception, a final test before apocalypse. Movements rose to demand governments cease listening altogether. In one chilling act, extremists sabotaged a radio observatory in Argentina, setting fire to its control building while chanting, "Silence is salvation." The streets. For ordinary people, the divide was lived in the streets. Cities saw waves of protest, some carrying banners reading "Welcome," visitors with images of stars and DNA spirals, others chanting, "Do not answer," and calling for the dismantling of radio telescopes. Universities were occupied by student groups demanding open access to all decoded material. Counter-protests formed outside, warning that science was leading humanity to its doom. On social media, conspiracy theories thrived. Some claimed the visitors had already landed in secret, governments hiding the truth. Others insisted the probes were weapons, broadcasting signals to destabilize Earth before an invasion. Every new scientific paper became fuel for suspicion. The philosophical break. Amid the chaos, a deeper philosophical fracture emerged. The optimists believed the flotilla was proof of kinship, an invitation to join a greater community. The pragmatists urged careful engagement, learn, but remain guarded. The isolationists demanded silence, arguing that by answering we endangered ourselves. The nihilists claimed the signals proved nothing but our own fragility, that even in contact, we were too fractured to rise together. No consensus held. Humanity was united only in argument, divided more sharply than ever. The unspoken fear. And beneath every debate, one unspoken question simmered. Why now? Why had the visitors chosen to answer when humanity was more polarized, more fragile, than at any point in recent history? Was it coincidence, or had they heard not only our greetings but our divisions? The flotilla kept singing. The diagrams kept unfolding. But on Earth, the most dangerous conflict of all was not between us and them. It was between us and ourselves. By February 2026, the flotilla was no longer just a subject for telescopes. One of its largest members, 3I divided by Atlas, was sweeping through the inner solar system on a trajectory that would bring it within 20 million kilometers of Earth, closer than Mars had ever passed in recorded history. It was an opportunity no scientist, engineer, or politician could ignore. For the first time in history, the debate shifted from whether to observe to whether to go. The choice was agonizing. Some argued that sending a mission was reckless. What if approaching the object triggered a response we could not predict? Others countered that refusing to go was madness. To let the first interstellar probe pass us by without inspection would be a betrayal of science itself. In late February, under enormous pressure from both scientific and military lobbies, an extraordinary coalition emerged. NASA, ESA, Roscosmos, CNSA, ISRO, and JAXA announced a joint emergency project, Project Encounter. For once, geopolitics bent to necessity. A mission built in months. Ordinarily, building a spacecraft for deep space rendezvous takes a decade. Project Encounter had less than a year. The only option was to adapt what already existed. SpaceX and Blue Origin volunteered heavy-lift rockets, capable of hurling payloads beyond Earth orbit. NASA offered hardware from its unflown Mars sample return prototypes. ESA contributed a solar electric propulsion module. China provided a miniaturized nuclear battery. Japan designed a deployable swarm of CubeSats. each carrying instruments. The patchwork came together in record time. The craft would not be elegant, but it would be fast. Its trajectory would be a high-energy burn, intercepting Atlas on its inward pass before the object swung away forever. Mission objectives. The public was told the mission had 3 goals. Close imaging. Capture high-resolution pictures of 3I divided by Atlas to determine its shape and surface. Spectroscopy. Analyze its materials directly, free from the distortions of Earth's atmosphere. Proximity radio. Attempt near-field detection of its transmissions to see if the signals differed when measured close up. Privately, a 4th objective existed, whispered in secure rooms, to test whether the object would react to approach. The launch. On the 19th of April 2026, under skies filled with millions watching live, the Falcon Heavy derivative carrying Project Encounter roared from Cape Canaveral. Hours later, a Long March rocket rose from Wenchang, carrying a second-stage propulsion module to rendezvous in orbit. For once, rival nations were partners, docking modules in low Earth orbit, assembling the most improbable spacecraft humanity had ever built. By May 5, it was on its way, a silver spear burning ion thrusters, accelerating on a trajectory that would place it alongside Atlas in just over 4 months. The world watches. For ordinary people, the mission became more than science. It was theater, hope, dread. News anchors called it the first visit. Children wore T-shirts with the mission patch. Artists painted murals of the probe reaching out toward a vast, shining sail. Religious groups prayed for safety or for restraint. Conspiracy forums warned it was a suicide run. But above all, the world held its breath. For the first time, humanity was not only listening or answering, it was going. The signal shift. And then, in June, 2 months into the mission's flight, the flotilla's transmissions changed. For the first time, the steady hydrogen line tones modulated into new sequences. Not primes, not diagrams, but something resembling rhythmic pulses, clustered into repeating frames. To some, it looked like music. To others, like instructions. But one pattern was unmistakable. When mapped onto a 3-dimensional grid, the bursts outlined a trajectory, an intercept arc. The very same path Project Encounter was taking toward 3I divided by Atlas. It was as if the visitors already knew. Were they welcoming us, guiding us, or warning us away? The mission pressed on, engines glowing in the dark. Humanity had crossed the threshold. There was no turning back. By late August 2026, Project Encounter had traveled more than 300 million kilometers, ion thrusters humming steadily, trajectory corrections executed with exquisite precision. Ahead lay 3I divided by Atlas, no longer just a faint point in telescopes, but a looming presence in the spacecraft's instruments, an object unlike anything humanity had ever touched. First images. At 10 million kilometers, the probe's cameras snapped its first high-resolution images. What returned was enough to stun mission control. 3I divided by Atlas was not a rock. It was not even a comet. It was a vast, wafer-thin structure, gleaming in reflected sunlight, its surface textured with patterns too regular to be natural. Long ridges ran parallel across its body, like ribs in an engineered panel. At its edges, struts or spars jutted at angles, giving it the profile of a fractured sail. Its color shifted with angles sometimes red, sometimes metallic silver, like advanced films designed to manipulate light. To the untrained eye, it looked unmistakably like a craft. The silence breaks. At 1 million kilometers, as the probe tightened its approach arc, the transmissions from Atlas shifted again. The steady hydrogen tone blossomed into pulses that mirrored the probe's telemetry burn, durations, rotation rates, even its communications carrier. It was as if Atlas had locked onto the probe and was talking back in its own language. The effect in mission control was chilling. Engineers whispered that the object was listening, watching, even studying. For some, it was proof of benign intent. Why mirror us unless to show recognition? For others, it felt like dissection. The swarm deployment. At 10,000 kilometers, the probe released its payload, 12 CubeSats, each the size of a suitcase, equipped with cameras, spectrometers, and radio receivers. They spread outward like a cloud, maneuvering on tiny thrusters to surround the object from multiple angles. Within hours, their instruments sent back the most detailed data yet. Spectroscopy. Surface materials reflected signatures unlike any known alloy or mineral patterns, suggestive of carbon composites doped with exotic elements. Thermal mapping. Temperatures on Atlas's surface remained improbably constant, despite uneven solar heating, proof of active thermal control. Radar imaging. Echoes revealed internal voids, chambers, and lattice-like structures inside. This was not solid stone, it was architecture, the unexpected maneuver. Then, at 4,000 kilometers, the unimaginable happened. Atlas moved, not subtly, not by drifting, but with unmistakable intent. Its rotation axis shifted, stabilizing so that one long edge aligned directly toward the approaching probe. And with that alignment, its radio transmission surged, no longer a narrow whisper, but a wideband burst that lit up the spacecraft's instruments like lightning. Telemetry spiked, hard drives filled. For 90 seconds, the probe was bathed in a torrent of data, more than had ever been received in the history of SETI. Then, just as suddenly, the transmission cut off. The object resumed its slow rotation, indifferent once more. The probe's fate. 3 hours later, as the probe attempted a closer pass at 1,000 kilometers, its signal went silent. First, a flicker of telemetry, then nothing. The swarm CubeSats continued to transmit, but the primary craft was gone. Whether it had suffered a power failure, interference, or something else, no one could say. Mission Control sat frozen. They had seen it alive. They had seen it turn toward us, speak to us, then fall silent again. The data, in the days that followed, analysts pored over the 90-second burst. It was not noise. Within the torrent lay structured modulation, recursive frames, diagrams, sequences too vast to decode at once. Early hints suggested map star positions marked with uncanny precision, perhaps a galactic chart. Others claimed to see engineering schematics, even language like symbols. Whatever it was more than we had asked for, more than we were ready for. The world reacts. On Earth, the probe's silence became myth. Some called it contact, others called it erasure. News feeds showed the final images of Atlas endlessly, an alien sail suspended against the stars, inscrutable and magnificent. And beneath every headline pulsed the same truth. Humanity had touched something not of Earth. It had looked back, and it had spoken. What it said, what it meant, would take years to unravel. But the silence of the universe was over. The 90-second burst from 3I divided by Atlas was humanity's first unambiguous message from another intelligence. But messages alone do not answer the deepest questions. They only sharpen them. By autumn 2026, Earth found itself staring not only at the data, but at a decision that could shape the fate of the species. The data war. The raw signal filled petabytes of storage. Universities, research labs, and intelligence agencies divided into factions, each decoding fragments, none grasping the whole. Some groups saw a star map, pointing to clusters tens of light years away, as if showing a home or network. Others swore it contained engineering blueprints, energy systems, materials, science far beyond our reach. A third camp argued the diagrams resembled laws, protocols for interaction, ethical constraints. For every interpretation, there was an opposite: map or trap, gift or lure, gospel or algorithm. The hydrogen code had widened into something vaster, and humanity could not agree on what it meant. The political divide. At the United Nations, the debate grew poisonous. Nations jockeyed for access, demanding priority for their scientists, their militaries, their corporations. Proposals for open distribution were blocked by fears of misuse. Rumors swirled of clandestine breakthroughs, new energy cells tested in secret labs, vaccines derived from alien biochemistry, weapons cloaked as research. The visitors had not sent armies. They had sent information. But information itself was a weapon, and humanity wielded it against itself. The public voice. Meanwhile, billions of ordinary people felt excluded from decisions made in closed rooms. Movements arose demanding transparency. The message belongs to all. Others demanded silence. Stop listening. Stop replying. In some cities, murals celebrated the flotilla as angels. In others, mobs burned effigies of telescopes. The visitors had become a mirror, reflecting not their nature but ours. The philosopher's warning. A circle of thinkers, scientists, theologians, artists, released a manifesto called the Terran Declaration. It argued that the moment was not about technology but about maturity. The probes ask us a question, it read. Do we choose fear or curiosity? Division or unity? We are free to refuse. We are free to destroy ourselves. But if we wish to walk among the stars, we must first prove we can walk together. The final transmission. Then, in November, as if sensing Earth's turmoil, the flotilla changed again. All probes, scattered across millions of kilometers, broadcast in unison a single narrowband message. It was not primes or grids this time, but a modulation pattern so simple it stunned everyone. Binary for 0 and 1, alternating steadily for exactly 12 minutes. To mathematicians, it was trivial. To philosophers, it was profound. It was as if the visitors were holding out their hand, saying, "We will start again, from the simplest truth. If you wish to continue, the choice is yours." And then the flotilla fell silent. The choice. Humanity stood at a precipice. We could answer again, build more probes, shout into the cosmos with all the power of our machines. Or we could remain silent, retreating into fear, letting the visitors drift past and vanish into interstellar dark. Neither path was safe. One risked exposure, the other risked irrelevance. But for the first time in history, the decision was not about whether we were alone. That question had been answered. The silence of the universe was broken. The only question that remained was one only we could answer. Do we dare to join the conversation?